My name is Joey Icavino, and today I want to discuss a problem that I had in mind while creating this project. We need more renewable resources because at some point we're going to run out, right? And one of these renewable resources that is a possibility is hydropower. Hydropower is water energy because hydro means water and power means energy. And we need to know what is the best way to make hydropower, right? Like in a turbine or in machines that people create. And I want to discuss if it's better to have more salinity or less salinity in water that we use for hydropower. So that leads me to this question. Does water salinity affect how much energy hydropower produces? And this is where my hypothesis comes in. If water salinity is increased, then it will not affect how much voltage is produced from hydropower. So that's what I think. But we'll see later on the true answer. So, what do we need to do this project in the first place? We need a voltmeter to measure it. We need to collect data, right? And then we need a way to transport water. So in this case, it would be a PVC pipe. And we need something to contain it. So this container here. And that's the basics of what we need. And there's other stuff that obviously there, like salt. So now we know what we need. How do we do this, and what do we do? So we're gonna pour 1 gallon of distilled water or fresh, because this is about 1 gallon right here, and then we're gonna put it together, right? Of course, that's what we need to do. So once we have everything set up here, we measure it with a voltmeter here. So when this spins, the voltmeter goes up. Right now it's not on, but if, let's say I switched it, right, and then I started spinning, it would go up. Of course, I don't have a very good angle of that. See? So then we repeat for a total of 3 trials to see what data we get. And we only got to do 2 because there was complications and some technical issues here. Well, the first time we did it, it kind of just went explode, and it was very wet. It was very bad. So, of course, we get rid of the water that's left over. And we add about 1.5 cups of salt water to the container because that's the ocean salinity, which I haven't told you yet, but salinity is how much salt is in water. So once we add that, we add the water and we do it again. We get our results, and this is where we come into the data chart. This is what I got for trial 1 and trial 2. And the results were the average for the freshwater average was 14.5 millivolts at maximum. And saltwater average at maximum was 16 millivolts. The formula used was trial 1 plus trial 2 divided by 2 equals the average maximum millivolts produced. So, that leads us to our conclusion. In the results, we have concluded that saltwater produces more voltage than freshwater. Some confounding variables, and confounding means confusing, like what could change this and what could make it not as accurate. So, some confounding variables are water flow and how much pressure was applied to the pulley and the wheel. In conclusion, based on these findings, people should build hydropower stations by the ocean. Not saying that you can't build freshwater stations, but according according to results that it's better to use salt water. And what were some variables that were in here? Well, salinity was an independent variable. It's the amount of salt water because it's what independent. It starts with I. It's what I change and how much salt I put in there, And then the voltage, the measurement of energy produced. It depends on how much salt is in there because it's the dependent variable. And the water temperature is the controlled variable because temperature is thermal energy. And energy means inaccurate results. So we have that. Make sure everything's the same, or else it would have gone wrong and we wouldn't get accurate results. No, we wouldn't. So that was my project on salinity and hydropower and how it affects it. And yeah. Thank you.